So good evening everyone. My name is Janaldon A. Avila and my topic for tonight would be mineral composition, texture, structure, and origin of igneous, sedimentary, and metamorphic rocks. So as discussed by the previous reporters, my classmates, we have three types of rocks, which are igneous, formed through the cooling and solidification of magma or lava, sedimentary rocks, formed by the accumulation of sediments, and metamorphic rocks, formed when an existing rock is transformed physically or chemically. So let's go to the origin of the three rocks. Origin of igneous rocks. Igneous rocks are formed from the solidification of molten rock material. Some form above or below the Earth's surface. We have two types of igneous rocks, which are intrusive or plutonic rocks and extrusive or volcanic rocks. Intrusive or plutonic rocks crystallize below the Earth's surface, and the slow cooling that occurs there allow large crystals to form, while extrusive or volcanic rocks erupt onto the surface, where they cool quickly to form small crystals. Some cool so quickly that they form an amorphous glass. Next is we have the examples of intrusive and extrusive igneous rocks. For intrusive igneous rocks, we have diabase, diorite, gabbro, granite, pegmatite, peridotite, and for extrusive igneous rocks, we have basalt, dacite, andesite, obsidian, pumice, and scoria. Now let's go to the origin of sedimentary rocks. Sedimentary rocks are formed on or near the Earth's surface, in contrast to igneous rocks, which are formed deep within the Earth. The most important geological processes that lead to the creation of sedimentary rocks are erosion, weathering, dissolution, precipitation, and lithification, in which erosion and weathering include the effects of wind and rain, which slowly break down large rocks into smaller ones. Erosion and weathering transform boulders and even mountains into sediments such as sand or mud. While dissolution is a form of weathering, a chemical weathering to be exact, in this process, water that is slightly acidic slowly wears away stones. These three processes create the raw materials for new sedimentary rocks. And as for precipitation and lithification, these are processes that build new rocks or materials. Precipitation is the formation of rocks and minerals from chemicals that precipitate from water, while lithification is the process by which clay, sand, and other sediments on the bottom of the ocean or other bodies of water are slowly compacted into rocks from the weight of overlying sediments. Now we have three types of sedimentary rocks. We have clastic, chemical, and organic sedimentary rocks. Clastic sedimentary rocks are formed from the accumulation and lithification of mechanical weathering debris, while chemical sedimentary rocks are formed when dissolved materials precipitate from the solution. And lastly, the organic sedimentary rocks are formed from the accumulation of plant or animal debris. We have here the examples of the clastic, chemical, and organic sedimentary rocks. For clastic sedimentary rocks, we have breccia, conglomerate, sandstone, siltstone, and shale. For chemical sedimentary rocks, we have chert, dolomite, flint, iron ore, and limestone. For organic sedimentary rocks, we have chalk, fossiliferous limestone, diatomite, and coal. Now let's go to the origin of metamorphic rocks. Metamorphic rocks arise from the transformation of existing rock to new types of rock in a process called metamorphism. Metamorphic rocks form when rocks are subjected to high heat, high pressure, hot mineral-rich fluids, or more commonly, some combination of these factors. Conditions like this are found deep within the earth or where tectonic plates meet. Exposure to these extreme conditions has altered the mineralogy, texture, and chemical composition of the rock. The process of metamorphism does not melt the rocks, but instead transforms them into denser, and more compact rocks. New minerals are created either by rearranging mineral components or reactions with fluids that enter the rocks. Pressure or temperature can even change previously metamorphosed rocks into new types. Metamorphic rocks are often squished, smeared out, and folded. And here we have two basic types of metamorphic rocks, which are foliated and non-foliated metamorphic rocks. Foliated metamorphic rocks have a layered or banded appearance that is produced by exposure to heat and directed pressure, while non-foliated metamorphic rocks do not have a layered or banded appearance. And we have here the examples of foliated metamorphic rocks and non-foliated metamorphic rocks. For foliated metamorphic rocks, we have gneiss, phyllite, schist, and slate. For non-foliated metamorphic rocks, we have hornfels, marble, novaculite, quartzite, and skarn. Now let's go to the mineral composition and texture of the three rocks, wherein texture describes the physical characteristics of the minerals, while composition refers to the rock's specific mineralogy and chemical composition. Okay. So the mineral composition of igneous rocks. Igneous rocks are composed primarily of silicate minerals. It's either dark or light, wherein dark silicates include olivine, pyroxene, amphibole, and biotite mica, while the light silicate includes quartz, muscovite mica, and feldspar. For igneous rock, the composition is divided into four groups. We have the felsic, intermediate, mafic, and ultramafic. These groups refer to differing amounts of silica, iron, and magnesium found in the minerals that make up the rocks. So let's go to the first mineral composition of igneous rocks, which is the mafic or basaltic composition. The term mafic was derived from the magnesium and ferrum or iron. So ma from magnesium and FiC or fic from ferrum or iron. Mafic rocks are richer in magnesium, iron, and calcium. They are also darker in color and denser. It is mostly made of dark minerals like pyroxene and olivine, which are rich in iron and magnesium and relatively poor in silica. Mafic rocks are low in silica in the 45 to 50% range. Mafic rocks makes up the ocean floor and many volcanic islands. The second one is the felsic or granitic composition. The term felsic was derived from feldspar and silica. Fel from feldspar and sic from silica. So felsic rocks are richer in potassium, sodium, and aluminum, and silicon. And compared to mafic rocks, they are lighter in color as well as density. Minor amounts of dark-colored minerals like amphibole and biotite mica may be present in these rocks as well. Felsic igneous rocks are rich in silica, ranging from 65 to 75%. And felsic rocks are the major constituent of continental crust. So the next one is we have intermediate or andesitic composition. So intermediate or andesitic composition is a composition between felsic and mafic. It usually contains roughly equal amounts of light and dark minerals, including light grains of plagioclase, feldspar, and dark minerals like amphibole. It is intermediate in silica in the 55 to 60% range. The last one of the four types of igneous mineral composition is the ultramafic composition. This composition is rare and it is high in magnesium and iron. Ultramafic composition composed entirely of ferromagnesian silicates. So let's go to the texture of igneous rocks. So texture is used to describe the overall appearance of rock based on the size, shape, arrangement of interlocking minerals, and crystal size. Factors affecting crystal size include rate of cooling, If slow rate yung cooling kay kanang gamay ra siya pero dagko yung crystals, pero if fast rate gani yung cooling kay daghan nga small crystals ang kanang ma-form. Pero if pas-pas kaayo ang iyang pag-form sa kuan, yung pag-cool, imo-form siya og glass. So let's go to the 6 types of igneous rocks textures. We have aphanitic, phaneretic, porphyritic, glassy, pyroclastic, and pegmatitic. So let's go to the first one, which is aphanitic. So aphanitic igneous texture or fine-grained texture. A means not, while phaner means visible. These textures cool rapidly, and they also have microscopic crystals and may contain vesicles or holes from gas bubbles. Aphanitic textures are rocks in contrast to phaneretic rocks, typically formed from lava which crystallize rapidly on or near Earth's surface. Because extrusive rocks make contact with the atmosphere, they cool so quickly, so the minerals do not have time to form large crystals. The individual crystals in an aphanitic igneous rock are not distinguishable to the naked eye. And examples of aphanitic igneous rock include basalt, andesite, and rhyolite. The second one is excuse me. The second one is phaneretic or coarse-grained texture, derived from the word phaner, which means visible. So this type of texture kanang hinay siya mukul, and this texture has large visible crystals. Phaneretic textures are typical of intrusive igneous rocks. These rocks crystallize slowly below the Earth's surface. As magma cools slowly, the minerals have time to grow and form large crystals. The minerals in a phaneretic igneous rocks are sufficiently large to see each individual crystal with the naked eye. Examples of phaneretic igneous rocks include gabbro, diorite, and granite. So the third one is porphyritic texture. Minerals form at different temperatures sa kanilang texture. Large crystals or phenocrysts are embedded in a matrix of smaller crystals or groundmass. Porphyritic textures develop when conditions during cooling of a magma change relatively quickly. The earlier formed minerals will form slowly and remain as large crystals, whereas the sudden cooling causes the rapid crystallization of the remainder of the melt into a fine-grained matrix. The result is an aphanitic rock with some larger crystals embedded within its matrix. Porphyritic texture also occurs when magma crystallizes below a volcano but is erupted before completing crystallization, thus forcing the remaining lava to crystallize more rapidly with much more smaller crystals. The fourth one is the glassy texture. Glassy texture cools very rapidly. Resulting rock is called obsidian. Glassy textures occur during some volcanic eruptions when the lava is quenched so rapidly that crystallization cannot occur. The result is a natural amorphous glass with few or no crystals. Examples include obsidian and pumice. The fifth one is the pyroclastic texture. From the word pyro, which means igneous, and clastic, which means fragment. Fragmental appearance produced by violent volcanic eruptions kani siyang pyroclastic. It often appear more similar to sedimentary rocks. These textures occur when explosive eruptions blast the lava into the air, resulting in fragmental, typically glassy material which fall as volcanic ash and volcanic bombs. The last one is the pegmatitic texture. This type of texture is exceptionally coarse-grained. It forms in late stages of crystallization of granitic magmas. Pegmatitic texture occurs during magma cooling, when some minerals may grow so large that they become massive. This is typical of pegmatites. So, mo to siya ang 6 textures sa igneous rocks. Now, let's go sa dere. So, igneous rock identification. So, did you know that igneous rocks are names are based on texture or the grain size and their mineralogic composition. So, na ko'y table dere. So, as makita ninyo sa table, if kanang yung texture is phaneritic or coarse grained, na yung chemical composition is granitic or felsic, ang ngalan sa rock is granite. Pero if phaneritic siya, dayon, andesitic yung chemical composition, ang iyang ngalan sa rock kay diorite. But if mafic siya, o phaneritic or coarse grained, ang ngalan sa rock kay gabbro. Same po siya if aphanitic siya, unya felsic iyang composition, ang rock is rhyolite. But if andesitic, it will become andesite, or if basaltic, it will become basalt. Kani siya diri sa ultramafic kay talagsara daw ni siya, mga rare daw ni siya mahitabo. So mo na siya. Kaning porphyritic, glassy, or pyroclastic. Sa porphyritic kay yun siya diri nga, porphyritic precedes any of the above names whenever there are appreciable phenocrysts. Sa glassy, obsidian or pumice, bisag unsa ang chemical composition, mo form siya og obsidian or pumice. Sa pyroclastic, mo form siya og yung name sa rock is tuff or volcanic breccia. As ma-observe ninyo, kanang ka-dark iyang color diri gikan sa granitic, light pa siya iyang color, pag abot sa intermediate or andesitic, medyo ni dark, then pag abot sa mafic, dark na gid siya, then pag abot sa ultramafic, dark na gid kaya iyang color. So, let's go to the textures of sedimentary rocks. We have 4 types of textures of sedimentary rocks. We have, first is the clastic, number 2 is crystalline, third one is cryptocrystalline, and the fourth one is fossiliferous. So, clastic. Clastic texture. Grains or clasts do not interlock, but rather are piled together and cemented. Boundaries of individual grains may be another grain, cement, or empty pore space. Overall, rock is generally porous and not very dense. Because clasts are only cemented together, grains are relatively easy to scrape off using a rock hammer point, or metal nail. If the grains are visible, all of the above characteristics may be noted. So, clastic sedimentary rocks is based on the grain size and shape, sorting and rounding of the sediments that form the rocks. And clastic sedimentary rocks has 2 types, which is microclastic texture, which clasts are not visible to the eye, and bioclastic texture, which are all of the clasts or grains are fossils. Now let's go to the grain size. Grain size is used to describe the size of the individual mineral grains, rock fragments, or organic material that are cemented together to form a clastic or chemical sedimentary rock. So, na-table dali. So, pasensya kayo if blur siya. So, if iyang diameter kay more than 256 mm, kuha na siya, boulder. If iyang diameter is 64 to 256 mm, ang particle type niya is cobble. If 4 to 64 mm, ang iyang particle type is pebble. If 2 to 4 mm yung diameter, ang particle type niya is granule. So, kung siyang boulder, cobble, pebble, o granule, ang sediment name ano niya is gravel. If ang iyang diameter kay 1/16 to 2, ang particle type niya is sand. If 1/256 to 1/16, ang iyang particle type is silt. If ang iyang diameter kay less than 1/256 mm, ang particle type niya is clay. So, kaya siyang silt and clay, iyang sediment name is mud. And sa sand, ang iyang sediment name po kay sand. Okay. So, let's go to sorting. Sorting is used to describe the grain size distribution or range of grain sizes in a rock. So, poorly sorted rocks contain a variety of different size grains. Poorly sorted rocks contain a wide range of grain sizes including fine, medium, and coarse. So, makita niyo sa picture, muna siya kanina sa ibabaw, kani siya. Kani siya mo kanang poorly sorted rocks. And the second one is well-sorted rocks, which contains almost all grains of the same size. So, kani siya mo well-sorted. Kani siya na. And the third one is moderately sorted rocks, which contains particles or relatively similar grains. Moderately sorted rocks may contain fine and medium grains or medium and coarse grains. So, kani siya moderately sorted rocks kay muna siya combination na ning duha. Now, let's go to the rounding. Rounding is used to describe the relative shape of the grains. Classifications are described as deviations from rounded or spheroidal grain shapes. Well-rounded grains are smooth with rounded edges. Kani siya, but tanawin niyo siya kay kuan, lami kay siyang pagka-forma kay well-rounded. Rounded siya dayon smooth pa jud. Dayon dirita sa moderately rounded grains, kuan siya in between the sharp angular edges of a poorly rounded grain and the smooth roundness of a well-rounded grain. As for the poorly rounded grains, it may be sharp or angular. So, muna siya poorly rounded grains or angular grains. Wait, nasa man ni. So, now let's go to the other types of sedimentary textures, which are crystalline, cryptocrystalline, and fossiliferous. Okay, now naman na to discuss no clastic. So, let's go to crystalline. So, crystalline textures. In this texture, crystals are visible and form an interlocking network. Unlike igneous crystalline textures, however, sedimentary crystalline textures are typically formed from one mineral throughout the entire rock. So, ika na siya sa usa ka mineral. An example ani niya kay limestone and rock gypsum. As for cryptocrystalline texture, there are no crystals visible, but the rock is composed of interlocking microscopic crystals. Such rocks are dense and typically non-porous. Cryptocrystalline rocks break with a characteristic conchoidal fracture. That is, the broken surface may smooth concentric lines resembling the inside of an oyster shell or broken glass. An example niya is kaning chert and flint. Kaning siya may chert, kaning may flint. And the last one sa types of texture sa sedimentary rocks kay fossiliferous. This type of texture are rocks containing abundance of fossils. The matrix may be either crystalline, cryptocrystalline, or clastic. Example niya is coal and fossiliferous limestone. Now let's go to the mineral composition of sedimentary rocks. Sa na-discuss na ko ganiha, na 3 types sa sedimentary rocks which are clastic, chemical, and organic. Sa mineral composition sa sedimentary rocks, i-divide na po siya king ani. So, clastic rocks is the most common sedimentary rock. It forms from cemented sediment grains that come from pre-existing rocks. Clastic sedimentary rocks form by the accumulation of mostly silicate mineral fragments. This includes mostly sandstones, mud rocks, conglomerates, and breccias. Then sa chemical sedimentary rocks or texture, they have crystalline textures. They are formed by precipitation of minerals from solution, and they consist of fragments or particles produced by precipitation from one living organism. Most of these rocks are limestones and cherts. While some limestones and cherts may form in this manner, evaporite deposits consisting of halite, gypsum, and other salts are most common. Kaning organic rocks, they accumulate from remains of organisms. So, clastic sedimentary rocks. We have breccia and conglomerate. These rocks are coarse-grained clastic sedimentary rocks. So, breccia is composed of coarse angular rock fragments cemented together. Breccia is a poorly sorted composite of a wide range of grain, size ranging from clays to gravels, which is greater than 0.062 to 2 mm. Breccia usually contain a framework of gravel-sized grains held together by a matrix of sands, silts, and clay. Breccia is similar to a conglomerate except that it contains of angular grains instead of rounded grains. The combination of poorly sorted predominantly coarse angular grains suggests that breccias form from a rapid deposition in high-energy environments such as steep gradient streams, glacial flood deposits, landslides, alluvial fans, or in association with faulting. Silica, calcite, and iron oxides are the most common cementing materials. There are many compositions of breccia. The mineral material and rock determine the composition that the angular fragments were produced from. The climate can also influence the composition of breccia. Now let's go to the conglomerate. Conglomerate is composed of rounded gravel cemented together. Conglomerate is a sedimentary rock made of rounded pebbles and sand that is usually held together or cemented by silica, calcite, or iron oxide. It is a stone similar to sandstone, but the rock particles are rounded or angular gravel rather than sand. Conglomerate is a coarse-grained rock that is often formed in river beds. The pebbles and sand can be composed of many different minerals, but it is usually quartz-based minerals. Now let's go to sandstone and shale. Sandstone is a sedimentary rock composed mostly of quartz sand, but it can also contain significant amounts of feldspar and sometimes silt and clay. Sandstones are medium-grained clastic sedimentary rocks. And na siya type na ang composition may determine. Quartz sandstone is more than 90% of quartz grains, while arkose mostly feldspar and quartz grains, and greywacke, which has sand grains surrounded by dark fine grain matrix, often clay rich. Sandstone rocks are composed almost entirely of sand-sized quartz grains cemented together through lithification. Sandstones comprise about 20% of all sedimentary rocks and are formed in a variety of different environments including rivers, marine, oceans and beaches, and glacial, or ice. The color of sandstone varies depending on its composition. The most common sandstones have various shades of red caused by iron oxide. In some instances, there is a purple hue caused by manganese. Now let's go to shale. Shale is a fine-grained, moderately to well-sorted rock formed by the compaction of well-rounded silt and clay-sized grains. Sediment deposited in lake bottoms, rivers, or deltas, floodplains, and on deep ocean floor. Kaya dito ni makita ang shale. Shale often contain fine laminations which helps impact facility to the rock. Facility is a term used to describe layered laminations formed by the compression forces exerted over long time periods. Shale usually contains about 50% silt, 35% clay, and 15% chemical materials. Many shales may also contain organic plant materials and fossils. Shale is characterized by thinly laminated layers representing successive deposition of sediments. Shale accounts for about 50% of all sedimentary rocks deposited on the Earth's surface. The sediments that form shale are most likely deposited very gradually in non-turbulent environments such as lakes, lagoons, floodplains, and deep ocean basins. Next one is the mudstone, siltstone, and claystone. Claystone. Claystone is a predominantly clay-sized grain non-fissile. While mudstone consists of a very silt-sized and clay-sized grains and are often well consolidated with little pore space. Mudstones do not contain laminations or facility, but they may contain bedding plane features such as mud cracks or ripples. Mudstones do not contain laminations or facility, Clay minerals are the most abundant minerals in mudstones, making up over 60% of all mudstones. Other minerals like quartz, feldspar, or carbonate minerals, organic compounds, And hematite also occurs sa sandstone. So sa siltstone are slightly coarser grained than shales and it lacks facility. Now let's go to chemical sedimentary rocks. We have here carbonates, which includes limestone and dolomite. Carbonates contain Carbonates contain CO3 as part of their chemical composition. Limestone is composed mainly of calcite. Carbonates mostly are biochemical but can be inorganic. It often contains easily recognizable fossils, and carbonates' chemical alteration of limestone in magnesium-rich water solutions can produce dolomite. As for chert is a hard, compact, fine-grained, and formed almost entirely of silica. Chert can occur as layers or as lumpy nodules within other sedimentary rocks, especially limestone. As for evaporites are chemically deposits formed when restricted bodies of saline water evaporate, precipitating out a range of minerals. Evaporites form when evaporating saline waters like lake or ocean. Evaporite deposits do not involve a single chemical precipitate, but instead they consist of chlorides, sulfides, carbonates, and borates. A common example of evaporites are rock gypsum and rock salt or asin. Now let's go to organic sedimentary rocks. We have coal and fossiliferous limestone. Coal is a sedimentary rock forming from compaction of partially decayed plant material. Organic material deposited in water with low oxygen content. Coal is made almost entirely of plant material and other organic deposits that have been buried for millions of years under elevated conditions of heat and pressure. Although the chemical composition of coal changes from its organic origins, it often retains fossilized imprints of plant leaves, bark, wood, and organisms that lived during the time that the organic materials were deposited. Now let's go to fossiliferous limestone. Fossiliferous limestone is any type of limestone made mostly of calcium carbonate in the form of the minerals calcite or aragonite that contains an abundance of fossils or fossil traces. The fossils in these rocks may be of microscopic or microscopic in size. Fossiliferous limestones may also contain considerable amounts of magnesium carbonate, and minor constituents are also commonly present, including clay, iron carbonate, feldspar, pyrite, and quartz. Now let's go sa sedimentary rock identification. So if ganiha sa igneous rock, kay ang gamit nila is katong texture niya or crystal size at niya mineralogic composition. Diri sa sedimentary rock, specifically sa clastic niya, ang iyang sediment particle o iyang description mo'y basihan sa name sa rock. So if yung sediment particle is gravel na ang description niya is rounded rock fragments, ang rock name would be conglomerate. If ang sediment particle is gravel, ang yung description kay angular rock fragments, rock name would be breccia. If yung sediment particle kay sand, ang description niya kay quartz, predominant visible grains, often thickly bedded, deposited structures such as cross-bedding common, iyang rock name kay sandstone. Now, if yung sediment particle kay sand, ang description is sandstone with more than 25% feldspar grains, iyang rock name kay arkose. And the rest niya, nakuhot dog basa kay hapit na time. And kung sa plastic sedimentary rock ganiya kay iyang gibasihan kay katong sa grain size, diri na po sa chemical sedimentary rocks, ang gibasihan na po niya is iyang texture and composition. Just like sa igneous rock kaniya nga akong discuss. So if iyang texture is clastic, na ang iyang composition is calcite fragments and calcite cement, white or gray bluish in color, fuses strongly in dilute HCl, iyang rock name kay limestone. And if crystalline siya na iyang composition is halite interlocking cubic crystals, iyang rock name is salt. and kaning the rest diri. Sa same pod sa organic sedimentary rocks, ang gibasehan po niya is texture and composition. If yung texture is clastic, niya composition niya kay clastic shell fragments, yung rock name is coquina. If yung texture is clastic, niya yung composition is microscopic shells of coccoliths, yung rock name would be chalk. If ang texture is cryptocrystalline, yung composition niya kay microscopic siliceous organisms, and recrystallized silica, yung rock name would be chert. And if yung texture is clastic, niya yung composition kay consolidated plant remains, the rock name would be coal. Now let's go to the textures of metamorphic rocks. Metamorphic texture. So metamorphic texture is the description of the shape and orientation of mineral grains in a metamorphic rock. Metamorphic rock textures are foliated or non-foliated. So let's go sa foliated textures. Foliated rocks typically appear as if the minerals are stacked like pages of a book, thus the use of the term folia, like a leaf. So, kaning foliated texture na siya yung mga lines like muna siya giluntod-luntod if lantaw ninyo sa picture. In order of increasing grain size, foliated textures are referred to as slaty, phylitic, schisto, and schistose. Then the corresponding rock types are called slate, phyllite, and schist. These rocks are not normally banded. The composition of the rock is uniform throughout the volume of the rock, while ang banded, kaning foliated texture is referred to as gneiss. Katong tulugan niya, katong slaty, phylitic, o schistose, kaya man sila banded. Pero kaning gneiss kay banded siya, na iyang corresponding rock type is gneiss. So let's go to the non-foliated metamorphic texture. Non-foliated rocks lack foliation or banding. Such rocks are mostly commonly composed of neither platy or needle-like minerals, but rather more equidimensional or more or less the same dimension in all directions. Non-foliated textures do not have lineations, foliations, or other alignments of mineral grains. Non-foliated metamorphic rocks are typically composed of just one mineral and therefore usually show the effects of metamorphism with recrystallization in which crystals grow together but with no preferred direction. The two most common examples of non-foliated rocks are quartzite and marble. So let's go sa marble. Marble is an example of metamorphic rock with non-foliated texture. Marble is a coarse-grained metamorphic rock formed from the parent rock, limestone or dolostone. So, yung parent rock or kay limestone or dolostone. Because it is formed from the limestone or dolostone, it is predominantly composed of the mineral calcite, which metamorphoses into various carbonate and other minerals. As calcite recrystallizes, all the grains are active simultaneously and grow to the same size and shape, which leads to its non-foliated texture. Different color schemes in marble are the result of impurities of the presence of weathered materials deposited in or near the limestone. So, kaning iyang color sa marble kay maapektahan siya sa kanang mga weathered materials ka nandool sa limestone. Now, let's go sa quartzite. Quartzite is a metamorphic rock formed under moderate to high-grade metamorphism that exhibits both foliated and non-foliated structure. The parent rock to quartzite is sandstone. Sandstone. Quartzite forms from the recrystallization of quartz grains in the sandstone, and often the resulting metamorphic rock will preserve vestiges of the original bedding patterns. Quartz is predominantly white in color, but can also contain pinkish or grayish shades depending on the presence of iron oxides. Now let's go to the mineral composition of metamorphic rocks. As rocks undergo metamorphism, original minerals in rocks change into new minerals that are more stable within the new pressure and temperature conditions. Common minerals in metamorphic rocks include quartz, feldspar, mica, calcite, and Hornblende. To identify metamorphic rocks through crystal size and mineral composition. So, kani siya, if mag-naming kuan kana metamorphic rocks, ang iyang gamit diri is iyang crystal size and ang iyang mineralogy. So, if iyang crystal size is very fine, iyang component kay clay minerals, tapos ang iyang parent rock or protolith niya is shale, the name of the metamorphic rock would be slate. Now, if iyang crystal size is fine, na ang iyang component is clay minerals, biotite, and muscovite, na if iyang kanang parent rock is shale Japon, na iyang rock name would be phyllite. If iyang crystal size is medium to coarse, na iyang component kay biotite, muscovite, quartz, and garnet, and plagioclase, tapos ang iyang parent rock kay duha, which is shale and basalt, the rock name would be schist. If iyang crystal size is medium to coarse, na iyang component is amphibole, plagioclase, and biotite, na iyang parent rock is basalt, the rock name would be amphibolite. If ang iyang crystal size is medium to coarse, na iyang component is plagioclase, orthoclase, quartz, biotite, amphibole, and pyroxene, tapos iyang protolith is tulo, basalt, granite, ug shale, the rock name would be gneiss. Na diri sa unfolded metamorphic rocks, if yung crystal size is fine to coarse, then the iyang component is quartz, tapos ang iyang parent rock is sandstone, the rock name would be quartzite. If ang iyang crystal size is fine to coarse, tapos iyang component is calcite, na iyang parent rock is limestone, the rock name would be marble. If ang iyang crystal size is fine, tapos ang iyang component is pyroxene, amphibole, and plagioclase, tapos iyang parent rock is shale, ang rock name would be hornfels. Now let's go to the structures of the three rocks. So, structures. Igneous structures are the physical features that result from the eruptions of volcanic magma or through the solidification of molten rocks from beneath the surface of the earth. So, namo to'y two types ganihang igneous rocks. Dili sa structure, igamit gyapon ni silang duha. So, under sa kaning intrusive igneous structures, they are formed below the earth's surface where magma is subjected to cooling and solidification. And na siya 8 types of structure, namely laccoliths, lopoliths, faccoliths, batholiths, stocks, seal, dikes, and volcanic neck. Katong discuss ni Echanes last Tuesday. Then as for extrusive igneous structures, these are formed by the cooling of molten magma on the earth's surface, and napo siya 8 kanang structures, which are pillow lava, lava flow, spherolithic structure, vesicular structure, myarolithic structure, amygdaloidal structure, columnar and orbicular structure. Now let's go to the intrusive igneous rock structure first. So the first one is a laccolith. A laccolith is a mushroom-shaped intrusion that develops beneath the Earth's surface when liquid magma surpasses its way between two horizontal layers of pre-existing rock to cause the overlying materials to bulge outward as the feature grows. With time, this usually results in the formation of tiny hills and mountains around the central peak. They are given the name mushroom-like features because their dome-shaped portions of the feature resembles mushrooms. The formation of laccoliths usually takes hundreds of years, and after a volcano has erupted, the dome takes a very extended period for it to surface to the ground. So, muna siyang pag-form sa laccolith. O, gikan sa ilalom, niagi diri ang magma, ni-form siyang murag dome-like. An example na to is laccolith Henry Mountain sa Utah, USA. The next one is lopolith. So, lopolith is a large, layered igneous intrusion that is distinguished by the convex downward bowl shape of its floor and whose top can either be flat or convex down. So, if katong laccolith ganiha kay muna siyag mushroom, kaning lopolith kay bali ani niya pa-down ang iyang dome. Padawn iyang shape niyo. Pa-down. Tapos yung top can be, pwede siya convex down or flat po siya. Ang example ani is Duluth Complex in Minnesota. If tanawon ninyo siya, mula siya ni down. Ni down yung curve. The next one is Facholith. Facholith is a layer of igneous rock which has the structure of a lens and which occurs in an invasive position in sedimentary rock. So, kani siya Facholith. Mula siya lens nga ni kuan siya sa mga ubang rock layers. Pero wala ko example ani niya kay wala ko kitang example sa internet man. So, move on ta sa next one. The fourth one is the batholith. A batholith is a large mass of intrusive igneous rock larger than 100 square kilometers in area that forms from cooled magma deep in the Earth's crust. Batholiths are almost always made mostly of felsic or intermediate rock types such as granite, quartz, monzonite, or diorite. So, tara siya. Ang magma mo, ana siya diri din. Mo-bulge na siya diha, mo-form siya, mura siya mountain ranges. An example na to is Sleece Mountain in British Columbia, Canada. Kani siya. Then the next one would be stocks. Sorry. Stock is an igneous intrusion that has a surface exposure of less than 100 square kilometers. So, nakalahi, pareha siya sa batholith, pero ang nakalahi niya, mas smaller ang stock. If katong kuan batholith ganiha, kay mo exceed siya kanang 100 square kilometers, kaning stock kay less than na siya sa 100 kilometers, so gamay ra siya. Then, example niya is kaning Nordmarkite stock in the Jevanim Valley, Maktishermon, southern Israel. So, gamay ra kayo siya compare sa atong Sleece Mountain ganiha. Now, let's go to seal. Seal, also called a sheet, is a flat intrusion of igneous rock that forms between pre-existing layers of rock. Seals occur in parallel to the bedding of the other rocks that enclose them. And though they may have vertical to horizontal orientations, nearly horizontal seals are the most common. Seals may measure a fraction of an inch to hundreds of feet thick up and to hundreds of miles long. So, muna siya seal. Pero mas common niya ang kanang horizontal seal. Another example, kaning Salisbury Crags in Edinburgh, Scotland, a seal partially exposed during the Quaternary glaciation. The next one is dike. A dike is a sheet of rock that formed in a fracture in a pre-existing rock body. Dikes can be either magmatic or sedimentary on origin. Magmatic dikes form when magma intrudes into a crack, then crystallizes as a sheet intrusion, either cutting across layers of rock or through an unlayered mass of rock. So, if kaning seal kay pahigda, kanipong dike is paslant siya. Mamani seal, mo ni siya dike. Another example dali na sa picture, kaning a magmatic dike cross-cutting horizontal layers of sedimentary rocks in Maktesh, Ramon, Israel. So, tawa siya, ni kuan siya, ni cut siya, patindog siya, pataas. Now, let's go to the last kuan, sa intrusive igneous structure. Lakulag ay sila. So, volcanic neck. A volcanic neck is also known as a volcanic plug or lava neck. It's a volcanic object created when magma hardens within a vent on an active volcano. When present, a plug can cause an extreme buildup of pressure if rising volatile charged magma is trapped beneath it, and this can sometimes lead to an explosive eruption. So, dili siya, kanang mga top, mga magma, kana siya dili. Another example is Devil's Tower in Wyoming, USA. Kuyaw ka siya lang tao. Now, let's go to the extrusive igneous structures. The first one is pillow lava. So pillow lavas are lavas that pillow lava or pillow structure. So these structures are observed in certain extrusive igneous rocks. It's characterized by discontinuous pillow-shaped masses ranging in size from a few centimeters to a meter or more in the greatest dimension, commonly between 30 centimeter and 60 centimeter. Pillow lavas are lavas containing characteristic pillow-shaped structures attributed to the extrusion of the lava underwater or subaqueous extrusion. Pillow lavas in volcanic rock are characterized by thick sequences of discontinuous pillow-shaped masses, commonly up to 1 meter in diameter. So if tanaw ninyo siya, mura siya unlan ng taon nga. Mura siya unlan. Pillow-shaped siya. Ang example na to is pillow lava near Wamaru, New Zealand. The next one is lava flow. Lava flows are streams of molten rock that pour or ooze from an erupting vent. Lava is erupted during either non-explosive activity or explosive lava fountains. So, kaya siya, lava flow. An example na to is Pahoho lava flow from Kilauea Volcano, Hawaii. Nag-take niya siya nga picture itong November 1985. So, muna siya, lava. The next one is spherulitic structure. These structures are identified by the presence of needle-like mineral grains in igneous rock masses. So if nantaw ninyo siya, muna siya na ibangag-bangag nga murag kamay sa mura siya kana bangag kabantay mo na injikan mo na muna yung mga bangag kuha gani sa needle ingani yung forma na siya mga bangag-bangag. The next one is vesicular structure. These structures are volcanic rocks that contain vesicles or holes that were formed by gas bubbles in the lava. So, muna siya, yung picture. Pero wala ko yung sample nga, kanang real life sample, kay wala ko kita sa internet. The next one is myelolytic structure. In myelolytic structure, the cavities formed during the cooling of lava are filled with some different minerals by joints or fractures in the rock, formed when the rock contracted most often during cooling. So, muna siya example niya. Mga cavities siya. Yung cavities kay lain-lain ang ni fill nga mineral. The next is amygdaloidal structure. In this structure, the vesicles of volcanic rocks may subsequently be filled by secondary minerals such as calcite and zeolites. If nantawan nyo sa picture kay, may ilhan nimong lain-lain yun yung minerals kay sa color pa lang daan. No? Tawa. Na. Then let's go to the columnar structure. These structures consist of columns that are separated by joints or fractures in the rock. Na, tara siya. Mag-form siya mga column. Then, lastly, sa extrusive igneous structure, kay orbicular structure. These are structures developed in certain phanerocrystalline rocks like granite or diorite due to the occurrence of numerous orbicules. It is sometimes mined as an ornamental stone. So, tawa siya. Na. Now, let's go to the sedimentary structures. We have 11 sedimentary structures. These structures are large-scale features of sedimentary rocks that result from physical or chemical processes. We have bedding, cross-bedding, graded bedding, mud cracks, ripples, dunes, anti-dunes, bioturbation, soil marks, rain impressions, and imbrication, which na-discuss na ni Echanes atong last meeting. So, let's go first to the bedding. Bedding is defined by the differences in color and texture, and also by partings or gaps between beds that may otherwise appear to be similar. Bedding is the separation of sediments into layers that either differ from one to another in texture, composition, color, or weathering characteristics, or are separated by partings, which are narrow gaps between adjacent beds. Bedding is an indication of changes in depositional processes that may be related to seasonal differences, changes in climate changes in locations of rivers or deltas, or tectonic changes. Partings may represent periods of non-deposition that could range from a few decades to a few millennia. Bedding can form in almost any sedimentary depositional environment. So, ang example niya is kaning the Triassic Sulphur Mountain Formation near Exshaw, Alberta. Excuse me, ma'am, padayon pa ko, ma'am. Taas pa, ma'am, napay 19 slides. Sige, ma'am. Sige, ma'am. So, 3 minutes, ma'am. Sige, ma'am. Sige ko. 3 minutes. Uy. Okay, let's go. So, second one is cross-bedding. It is a bedding that contains angled layers within otherwise horizontal beds, and it forms when sediments are deposited by flowing water or wind. So, kanina example nato is cross-bedded Jurassic Navajo Formation, Aeolian Sandstone at Zion National Park in Utah. So, the next one is the graded bedding. Graded bedding is a sediment deposit characterized by coarse sediments as its base, which grade upward into progressively finer ones. Graded bedding is usually explained as the result of large amount of mixed sediment being discharged into quiet water. An example nato is kaning graded turbidite bed in Cretaceous Spray Formation rocks on Gabriola Island. The next one is ripples. Kanishang ripples are associated with the formation of cross-bedding. And ripples can help determine the flow direction as they tend to have their steepest surface facing in the direction of the flow. Natay two types sa ripples, which is symmetrical ripple marks and asymmetrical ripple marks. Symmetrical ripple marks are often found on beaches, and they are created by a two-way current, for example, the waves of the beach. While asymmetrical ripple marks are created by one-way current, for example, in a river or the wind in a desert. So, muna siya example sa kaning symmetrical wave ripple sa Namgon, Mongolia. Now, let's go to mud cracks. Mud cracks are sedimentary structures formed as muddy sediments dries and contracts. Crack formations also occurs in clay-bearing soils as a result of reduction in water content. So, kanin siya example. It's a mud crack in volcanic mud at a hot spring area near Maivatten, Iceland. Next one is dune. Dune is a landform composed of wind or water-driven sand, and it typically takes the form of a mound, ridge, or hill. An area with dune is called dune system or a dune complex. And muna siya example sa dune. Next is anti-dune. Anti-dunes are share similar characteristics with dunes, but are formed by a different opposing process. Anti-dunes come from fast-flowing upper flow regimes. So, muna siya example si anti-dunes. And let's go to bioturbation. Bioturbation is the result of organisms burrowing through soft sediment, which disrupts the bedding layers. These tunnels are backfilled and eventually preserved when the sediment becomes a rock. So, kanin siya, mo pasok dira sa ng mga butang niya. Nata example diri ano siya itsura sa Aries Valley Formation. Now, let's go sa soil marks. Soil marks are features that are preserved when a coarse sand or silt layer deposits onto mud. So, natawag yung mga deposits diri nga na siyang itsura. Sa siya Ladakh Range, India. Now, let's go sa raindrop impressions. Raindrop impressions are small pits or bumps found in soft sediment. They are generally believed to be created by rainfall, and they may be caused by other agents such as escaping gas bubbles. So, mga siya yung itsura. Mga siya mga bangag-bangag. Next is imbrication. The last one sa sedimentary structure. Imbrication is a stock of large and usually flat clasts that are aligned in the direction of fluid flow. Imbrications are useful for analyzing paleocurrents or currents found in the geologic past, especially in alluvial deposits. So, here is an example, an imbricated fabric from debris of the Rambla de la Sierra, Spain. Now, let's go sa metamorphic structures. We have cataclastics, schistose, gneiss, maculose, and granulose structure. First one is cataclastic structure. These structures result from the crushing and granulation of minerals and rocks or cataclases through the application of stress at low temperatures. Due to this, the resistant minerals in rocks may remain unaffected while the softer minerals are powdered to fine material. So, may siya picture sa cataclastic structure. The next one is maculose structure. These structures are characterized by spotted appearance of the rock that may be caused due to the formation of large-sized crystals called porphyroblasts. So, if makita niyo sa picture kay muna siya kanang mga nailamigas na pagka-spots niya, na yung mga black na spots. The next one is schistose structure. Due to the predominance of metamorphic rocks such as mica, chlorite, talc, and amphiboles, which under the dominant influence of directed pressure in metamorphism, it forms layers arranged in more or less parallel bands. So, if makita niyo siya, parallel yung mga bands niya dito. Now, let's go to the granulose structure. Due to the predominance of equidimensional minerals such as quartz, feldspar, pyroxene, calcite, and etc. in a metamorphic rock, these structures are formed. They are formed as a result of recrystallization of pre-existing rocks under uniform pressure and high temperatures. So, muna siya example sa granulose structure. The last one is the gneiss structure. A gneiss structure is a banded structure in which the minerals have been segregated into discontinuous bands, and each of which is dominated by one or two minerals. These structures are light-colored bands commonly contains quartz and feldspar, and the dark bands are commonly composed of hornblende and biotite. A rock with gneissic structure is called a gneiss. So, muna siya example niya. If makita ninyo yung bands, kaya nga ni siya. Now, lastly, let's go to my geological wonder of the world. We have Shilin Stone Forest in China. Shilin Stone Forest is a group of natural rock formations located in the province of Yunnan in China in Asia. The rocks of Shilin Stone Forest are made of limestone, shaped by constant erosion and weathering. There are thousands of rocks in the Shilin Stone Forest, and the rocks have the appearance of petrified trees or stalagmites. This forest sits on an area covering approximately 350 square kilometers, and it is a highly popular tourist attraction with various accommodation options nearby. Seven main parts make up Shilin Stone Forest, including the greater and lesser sections, and areas that contain caves such as Dion Cave and the Lake Chang. According to the native folklore, the area of Shilin Stone Forest is the location of where a Yi woman called Ashima was born, who is said to have turned to stone when she failed to receive permission to marry her true love. Strange shaped rocks that resemble elephants, lions, and other forms that can be found throughout Shilin Stone Forest. And the tallest formation of Shilin Stone Forest reaches 30 meters in height. So that's all. Thank you.